So first, we want to solve this linear system. We're given the augmented matrix. What we want to do is reduce the matrix to reduced echelon form. Of course, first we'll obtain echelon form through the forward phase of the reduction process. Then we will obtain the reduced echelon form in the reverse or second phase of the row reduction process. So, as an illustration, we're going to use our 3 elementary row operations. The first operation that I want to employ upon this matrix, or apply to the matrix, is switching row 1 and row 2. So I will do that. Row 2 becomes, the original row 2 becomes the new row 1, and vice versa. And of course, nothing happens to row 3. So we'll recopy that or leave it the same. So what we're saying is now this is the first step of the reduction. Now for illustration, I'm going to reduce this in a way that illustrates some of the row operations. As we become more proficient, we will do this a little more quickly. Okay. So what we want to obtain is a 0 in the second row, first column. I'm writing it in there now to show you what we want to obtain. So we do that through the type 1 elementary row operation. We'll say -3 row 1 plus row 2. Of course, we put the result back into row 2. So let's do that. We'll do that mentally or on the side. We'll multiply -3 times each of the entries in row 1 respectively, and then add to the corresponding entry in row 2. So -3 times -4 is 12. 12 plus 2 is 14. -3 times 2 is -6. -6 plus -1 is -7. -3 times 9 is -27. -27 plus -1 is -28. Okay. Now, we also want to put a 0 in the first entry of row 3. This is the part of the forward phase of the reduction process. So to do that, we will do 4 times row 1 plus row 3, putting the result back into row 3. So 4 times -4 is -16. -16 minus 6 is -22. 4 times 2 is 8. 8 minus 2 is 6. 4 times 9 is 36. 36 minus 2 is 34. Now, we've achieved our zeros. We've cleared out, as they say, the entries below the leading entry in row 1. Now we want to put in the 2-2 entry. We want to make that a 1. How do we achieve that? Well, we do that by using our second type of elementary row operation. We're going to multiply row 2 by 1 over 14. Now we're not doing anything to the second row, so we'll leave that. And the first row, by the way, we'll leave those unchanged. Okay. And you see, when you have a 1 as a leading entry, those are very easy to deal with in terms of the decision-making process in the row reduction. It makes the decisions easy. Perhaps not the arithmetic, but it makes the decisions easy. What decision am I referring to? Well, we're asking ourselves, we're considering what number do I multiply 1 by so that when I add it to -22, I get a 0 in the 3, 2 position. Well, that's just 22. It's just the additive inverse of negative 22. And again, you'll see in the forward phase of the process, which is the process in which we're engaged, you use the higher level rows to produce zeros in the lower level rows. Okay. So 22 times negative 1/2 is negative 11. Negative 11 plus 6 is negative 5. 22 times negative 2 is negative 44. Negative 44 plus 34 is negative 10. So continuing our row reduction, again, very slowly, methodically. We can do this more quickly as we become more expert, but I'm illustrating the various types of operations that we may employ, not how to do the row reduction more rapidly. So now again, I would like to make this a 1 in the third row, third column. So of course we'll just do negative 1/5 row 3. Now notice we don't say divide row 3 by 5. Technically, there is no division in terms of elementary row operations. It's always multiplication. All right, so now we have echelon form. If you see on we have a lower triangle in our matrix. And the forward phase of the reduction is complete. So now what we want to do is, on the reverse phase, to make those numbers zeros. And again, on the reverse phase, we use the lower rows to alter or place zeros in the higher rows. So here we'll do 1/2 row 3 plus row 2. And the beautiful thing about the reduction process, these entries and above the 2 zeros in the bottom don't change, so that's good. We don't have to engage in the arithmetic there. 1/2 times 2 is a 1. 1 minus 2 is minus 1. And now we want a 0 in the first row, third column. So what would we choose? We would choose a minus 2 row 3 plus row 1, putting the result back into row 1. And minus 2 times 2 is minus 4. Minus 4 plus 9 is 5. And we're almost home. Recopying the third and second rows since they're complete. Finally, we want to put a 0 in the first row, second column. We achieve that by using the second row. We say 4 times row 2 plus row 1. Four times minus 1 is minus 4, plus 5 is 1. So we see our matrix is in reduced echelon form, and now we may read the solutions from the augmented matrix that we see here in the final step. That is, x is equal to 1, y is equal to minus 1, and z is equal to 2. Now that's assuming that our 3 variables that comprise this system would have been x, y, and z. Sometimes they are x1, x2, and x3. But in any event, we have the solutions and we have solved the system.